last time we derived the following, right? Given a point x naught, y naught on a parametrized curve, what's the slope of the tangent line at that point? And also, what's the concavity of the curve at that point? Okay? And we said, well, the slope of the tangent at the point x naught, y naught, assuming that this point occurs at t naught. Okay? So this point is traced at t naught, right? The parameter t. And we said, well, the slope will be given by dy dx at x naught. And we said also that the concavity will be given by what? The concavity will be given by the second derivative of y with respect to x. Right? That's what's going to give us the concavity. Now, we got two formulas for them. And formula number one, that's for slope. What's the slope of the tangent line at the point x naught, y naught? Well, the slope is given by dy dx at x naught, and we said that the value dy dx is the same as dy dt divided by dx dt. dy dt divided by dx dt, that's dy dx. Okay? And how about concavity? Well, the second derivative at x naught, and the second derivative of y with respect to x is given by d dt of dy dx divided by dx dt. Notice that the denominator in both formulas are the same. Okay? So in the numerator of the second derivative, I have d dt of dy dx. So you're taking the derivative of dy dx with respect to t. And we're going to do some examples today in a bit. Okay? So those are the formulas to be used. Any questions, anybody? Anything that didn't make sense last time? All right, so let's go over a big example here, and I'm going to try to go over all sorts of concepts that you're going to need to do the homework on section 10.2. Okay, so every single parts that I'm going to do here, you need to know that for your homework. Now, first of all, let's find the x intercepts. So C is a curve. The x coordinate of the curve is given by t squared. The y coordinate of the curve is given by t cubed minus 3t. T goes over the interval from negative infinity to positive infinity. How do I find x intercepts? So x intercepts means the points on the x-axis where the points where the curve crosses the x-axis, right? And how do I find that? Well, for the x-intercepts, what do we know about y-coordinate? 0. So we are going to set y to be 0, and then we'll try to solve for t. So if y is 0, then we know that t cubed minus 3t, that's the value of y, and that would be 0. And if that is 0, then I can factor out t, and then write it as t squared minus 3 equals to 0. And notice that then I can get well, let me write it here. And then I get t times t plus root 3 times t minus root 3, right? Equals to 0. So that would mean that I get the values of t will be t equals to 0, or t equals to negative root 3, or t equals to positive root 3. So there are possibly three x-intercepts. Now for each value of t, I have to figure out what is x and y. So when t is 0, what's the value of x? The value of x would be 0, and what would be the value of y? 0. So when t is 0, I get the point 0, 0 as the x-intercept. Okay, when t is When t is negative root 3, what's the value of x? 3. And what's the value of y? Of course, y would be 0, right? Because these are x intercepts. So this is when t is 0. Sorry, t is negative root 3. And what am I getting here? Again, I get 3, right? And y is 0. This is when I get, this is what I get at time root 3. So if you think of the curve as the path of a moving object, we are basically saying the moving object is tracing the point 3, 0 twice. Right? You are tracing the point 3, 0 twice. Once at t equals to negative root 3, another time at t equals to positive root 3. And of course you have the other intercept 0, 0. That's the origin. Okay, now let's look at y-intercepts. Y-intercept would mean that I said what? I have to set y-intercepts are points on the y-axis, and for them x is what? 0. What is x? X, the formula for x is t squared, right? And so the only thing that I get is t is 0. And when t is 0, I know exactly what point I get. So I don't really get any new points. I get the origin again. So that's the only y-intercept. Clear? Okay. Next question. Find the equation of the tangent line to the curve C at the x-intercept at the let me actually change the problem a little bit. I'm just going to say at the x-intercept 3, 0. I want to find the equation of the tangent lines to the curve C at the point, at the x-intercept 3, 0. Why am I saying tangent lines? Because I know that there are, I know that the curve is tracing the point 3, 0 how many times? Twice. So there might be at two different tangents. Remember, I showed you an example of a loop, and then at the same point P, there might be two tangents, right? Because remember, we got when t is negative root 3, I get the point 3, 0. When t is positive root 3, I also get the same point. So I know that the curve is tracing the point 3, 0 twice. Okay, and now in order to find the equation of the tangent lines at the point 3, 0, I need to know the slope of the tangent lines there, right? So what is my slope formula? We know that the slope at t0 is given by what? dy dt at t0 divided by dx dt at t0. That's the formula we derived last time. So I am going to use that to come up with the slopes. So first of all, let's find out the slope when t is negative root 3. So when t is negative root 3, what's the slope? Oh, by the way, what is dy dt? Look at the formula for y. What is dy dt? Three t squared minus 3. And then what is dx dt? What is dx dt? 2t. Because I am evaluating them at t0, let's just write t0 instead of t. So the dy dt is 3t squared minus 3, and dx dt is 2t, right? Everyone sees where they're coming from? Remember, y was t cubed minus 3t. So then you get the derivative 3t squared minus 3. Now, what is the slope then when t is negative root 3? When t is negative root 3, you're going to get 3 times what? Negative root 3 squared minus 3 divided by 2 times negative root 3, right? So what is that equal to? What is that equal to? What am I getting? I'm getting 6 divided by 2 times negative root 3, right? What is that? Negative 3 over radical 3. Let me just say this is negative root 3. Okay, so what's the equation of the tangent line? Let me just say tangent equation. I'll be very sloppy with my words here. Tangent equation at t equals to negative root 3 is what? We know we are looking for the tangent at what point? The tangent at the point 3, 0. So I know a point on the tangent. I know the slope. So slope intercept formula would be what? Y minus what? Times the slope here equals to the slope times x minus what? Y minus what? 0. X minus 3. Everybody's okay? Everyone is okay with that? Okay, can you see what would be the slope at t equals to positive root 3? Yeah, it will be positive root 3, right? It will be positive root 3. And then the tangent equation at t equals to positive root 3. What's the only change? I am going to have, this is not negative, so positive root 3 times x minus 3. So I have 2 distinct tangents at the point 3, 0. Any questions on that? Is that okay? All right. Part 4. Part 4 says, do you need more time to write that down? Part 4 says, find the points on the curve C where the tangent lines are horizontal. Find the points on C where the tangent lines are horizontal. Well, if the tangent lines are horizontal, what are their slopes? 0. So I basically want to find the points on the curve where the slopes are 0. And again, once again, we know the slope formula, right? We know that the slope at t0 is, we want the slope to be 0. And so we know that the slope formula is dy dt divided by dx dt. So I want to solve for t0 from that equation. I want to find values of t0 for which the slope would be 0. Now, when is this slope 0? Can anyone tell me? When is this slope 0? When the numerator is 0, but the denominator is not 0. Because if both of them are 0 at the same time, then this quotient is undefined, right? This quotient will not be 0. If both numerator and the denominator are 0 at the same time, then this slope is undefined, right? It's not going to be 0. So I want the numerator to be 0, but the denominator to be non-zero, right? Everybody's clear? So, okay, I want, so then, well, what is dy dt? We know that dy dt was what? 3 t squared. So I'm going to write t naught squared minus 3, right? Divided by, what was that? 2t. I want that to be 0. And then, so I want the numerator, so I want dy dt at t naught, I want that to be 0. I want that to be 0, but that means 3t0 squared minus 3 is 0. And that means, what is t0? t0 squared would be 1. Yeah, you're right. t0 would be plus or minus 1. Okay? Now, let's make sure that the denominator doesn't vanish at those values of t0. So if I look at dx dt at plus or minus 1, notice that I am not getting 0. Okay? So now I know that this. Now I know that for t0 equals to minus 1 and t0 equals to 1, for these two values of t, I get horizontal slopes, right? So can someone tell me then what are the corresponding points on the curve to these values of t? So what is the value of x corresponding to t equals to negative 1? 1. What is the value of y? I think this is positive 2, right? And then this would be x is still 1, and y is, this time is what? Negative 2, right? So I mean, let's go back to y, the y definition. So I am plugging in 1. If I plug in 1 here, I get 1 minus 3, so that's negative 2. If I plug in negative 1, I get negative 1 plus 3, so that would be 2. So 2 and negative 2. Okay, so we know exactly the points where the tangents are horizontal. Right? Those are my answers to the question in part 4. Everybody is okay with that? Questions, concerns? No? No? All right, so let's look at the part 5. Part 5, we are saying find the points where the tangent lines are vertical instead of horizontal. So when will that happen? Let me do some thought process here. If you have a curve where you have a vertical tangent, how should the curve look like near that point? So I'm saying, let's say I have a point, and at that point, the tangent line is vertical. So how should the curve look like in a very small portion around that point? Well, if the tangent line here is vertical, right? That means I have a tangent line which is vertical. So near that point, the curve must be looking like this, right? Am I making sense? So notice that near such a point where I have a vertical tangent, near such a point, you cannot think of y as a function of x, right? Can I think of y as a function of x? Oops. If you look at the red curve, right, can I think of y as a function of x via that curve? Well, it doesn't satisfy the vertical line test, right? So think about the x-axis and the y-axis like this. So this is the x-axis, this is the y-axis. If you look at the red curve, I have a vertical tangent at the point. Let me use a black color here, black point. And the red curve can't give you a y as a function of x. It doesn't give you y as a function of x. Okay, because it doesn't satisfy the vertical line test, right? However, notice that I'm going to change my view. I'm going to think of x as a function, but notice that I can think of x as a function of y, right? So think about, change the role of x and y. Now look at the plane in a different way, horizontally. Then I can think of x as a function of y, right? I can think of x as a function of y. Now x as a function of y, what is dx dy then? What would you say dx dy is? What do you think dx dy is? No, I mean think of this curve. You're thinking of this curve. You are thinking of x as a function of y. So think about this y-axis being the x-axis, and x-axis being the y-axis. Then what's the slope of that tangent line? 0, right? The slope of the tangent line would be 0 if I think of x as a function of y. So dx dy would be 0. My point is, if I have a point where I have a vertical tangent, it would mean that dx dy is 0. Everybody's okay? Dx dy would be 0. So what is dx dy? Well, dx dy would be basically the opposite of dy dx. Dx dy would be the opposite, multiplicative inverse of the dy dx. What was dy dx? Dy dx was dy dt over dx dt. This one would be the opposite, dx dt over dy dt. And I want that quantity to be 0, right? I want that quantity to be 0. So once again, when will this quantity be 0? This quantity would be 0. This quantity would be 0 when dx dt is 0, right? And dy dt is not 0. Because if both of them are 0, then the ratio is undefined. It's not going to be 0, right? If both of them are 0, the ratio is not going to be 0. Right? So, I want to figure out then, when is dx dt 0? Dx dt 0, well, that would mean t squared, right? Dx dt is t squared, and that would mean t is 0, right? And notice that if you look at dy dt, at 0, that's not going to be 0. Go back to the formula of dy dt, you'll see that dy dt at 0 isn't 0. So that tells me that I have a vertical tangent. I have a vertical tangent at the point t0. Let's figure out the corresponding x and y value. Well, we already know this point. This was the x-y intercepts, right? So this was 0, 0. This was the origin. So we see that at the origin, we have a vertical tangent. Making sense? Everybody's okay? All right. So that was part 5. Part 6. What is part 6? Part 6, we are going to analyze the component functions x and y as functions of t. That is, what I want to figure out is how is x increasing and decreasing, and how is y increasing, decreasing as a function of t. Everybody's okay? What I'm trying to do in part 6? Part 6, determine where x is increasing and where x is decreasing. We can use our Calc 1 knowledge, right? In Calc 1, we learned how to find how a function is increasing and decreasing by using the derivative, right? Now, just because you learned a method doesn't mean you should always use it. Maybe sometimes the problem is easier than that. Well, x is t squared. I feel like t squared is my friend, right? It's a function that I know very well. What's the graph of t squared as a function of t? Parabola opening upward, right? So do I know exactly how it behaves? Well, what's the value of x at 0? 0. Okay. On the left side of 0, is x increasing or decreasing? If you look at the parabola, right, here is 0, right, y-axis, it's decreasing on the left side of 0 and increasing on the right side of 0, right? So I know that x is decreasing here, and I know that x is increasing after 0. Two questions that we need to answer is, where is x decreasing from? So when t is at negative infinity, where is x? When t is at negative infinity, where is x? X is at infinity. When t is at infinity, where is x at? Infinity as well, because it's t squared, right? When t is big and negative, t squared is big and positive. When t is big and positive, t squared is big and positive. So I know this is what's happening for 2x. So that's it for x. Okay, we're going to do the same thing for y. So now we want to determine where y is increasing and decreasing. But y is a little bit more complicated looking than I wouldn't call t cubed minus 3t my friend, because I don't know right away what the graph is. But let's get some help from Calc 1. Okay, so in Calc 1, what did we do? Well, you have y, you look at the derivative of y as a function of t, and what is that? 3t squared minus 3, and you want to know when is this derivative 0, right? To find the critical points. So when is this derivative 0? The derivative is 0 when t, what does it mean? It means that if I look at that equation, then I know that what is t squared? What would be t squared? T squared would be 1, and then t would be plus or minus 1, you're right. T would be, so that implies that t is plus or minus 1. So I get two values of t where y prime is 0. Those are negative 1 and positive 1. I label them on the real axis. And now I want to figure out whether y prime is positive or negative. So look at y prime. Is y prime positive or negative on the left of negative 1? On the left of negative 1, for example, I have negative 2 on the left of negative 1. Plug in negative 2. Plug in negative 2 in the formula for y prime, and you get plus. You're right. So I know that I have plus here. And what is happening between negative 1 and 1? Well, between negative 1 and 1, I have 0. Plug in 0 for y prime. You get negative 3. So I know that it's negative throughout this interval. And then after 1, what's happening? Positive again. Okay, so what can I say then? I can say that y prime is increasing until negative 1. What's the value of y at negative 1? What's the value of y at negative 1? What's the value of y at negative 1? Plus 2, right? And then I know that from negative 1 to 1, it's decreasing. And what's the value of y at 1? Is negative 2. And then after that, it's increasing. But there are two questions that I have to ask here. One is, I know that as t goes from negative infinity to negative 1, y is increasing, right? But I have to figure out, as t goes from negative infinity to negative 1, y is increasing. So I need to know what's happening to y at negative infinity. So when t is at negative infinity, what can you say about y? When t is at negative infinity, y is at infinity. Negative infinity, right? Because it's t cubed, right? Y has the t cubed. So when t is at negative infinity, t cubed would be at negative infinity. So you know that it's going to be negative infinity. When t is at positive infinity, then y would be where? Positive infinity. So I know everything about y that I need to know. Okay. If I want to sketch the graph of C, I need to know one more thing, which is the concavity. Okay. What's the concavity of the curve? Okay, so if I want to know the concavity, I need to know the second derivative of y with respect to x, not t. So let me know if you're done with part 7, and then we're going to move on to 8. Okay. In number 8, I want to come up with the concavity, but before that, I need to know what's the second derivative of y with respect to x. So I know the formula, right? I know that dy, the second derivative of y with respect to x is d dt of dy dx divided by dx dt. Now remember what dy dx is, right? dy dx was dy dt over dx dt, and we know that dy dx is then 3t squared minus 3 divided by 2t, right? We found this before, right? dy dy dt was 3t squared minus 3, dx dt is 2t. Now what am I doing in my second derivative here then? What is it equal to? Well, I know the denominator already, right? What's the denominator? Dx dt, which is what? 2t. Now, in the numerator, what goes? It's the derivative of what? It's the derivative of this ratio, right? You're taking d dt of dy dx. dy dx is this guy. So you have to take the derivative of that with respect to t. And if you're doing that, you need to use what? Quotient rule, maybe? So let's go ahead. If I use the quotient rule, I'm going to get a quotient, of course. What goes in the denominator? What goes in the denominator if I'm applying the quotient rule? 4t squared. Okay, what goes in the numerator? What am I going to get? I'm going to get the denominator first, multiplied by what? The derivative of the numerator is what? 6t minus the numerator 3t squared minus 3. So I have the numerator multiplied by what? By the derivative of the denominator, which is 2. Okay, I need to simplify that. What am I getting then? I'm getting 12t squared minus 6t squared plus 6, isn't it? Do you realize that 4t squared and the 2t that I have together, they will give me 8t cubed? Can I simplify it this way? Because what I have here is 2t divided by 1, right? This 2t divided by 1 is there, right? So when you flip it, you are going to get what I have there, right? Is everybody okay with the algebra that I did? Okay. At this point, maybe one more line, because I can still write it as what? 6t squared plus 6 over 8t cubed. Fine. So that's the second derivative, and now I need to know concavity by using the second derivative, right? So that will be part 9. First, let me give you a second to finish it off. Questions, anybody? No? Okay, how do I come up with the concavity? Well, just like I did in Calc 1. What did I do? In Calc 1, figure out where the second derivative is what? Yeah.
So is our answer for part 8 is 6t squared plus 6?
Part 8 is, the answer is, let me use red. That's the answer. Here I only wanted to remind you what was dy dx. We computed dy dx in part 3 or so. I just wanted to remind you what that was. Yeah, the final answer is 6t squared plus 6 over 8t cubed. Okay, now we want to know concavity. In order to figure out the concavity, I need to know where the second derivative is positive, where the second derivative is negative. And in order to do that, I have to first figure out what are the critical points. Critical points means where the second derivative is what? 0 or doesn't exist, right? 0 or doesn't exist. Where is the second derivative 0 or does not exist? Now, if you look at the second derivative formula, notice that it can never be 0. Why? Look at the numerator. The numerator is strictly what? Positive. The numerator is at least 6, right? Because t squared is always non-negative. So at best, t squared is 0. So the numerator of the second derivative is always positive. So I'm never gonna get 0. So the only other thing to look at is when is this guy undefined at 0. So the only point I care about here is 0. So this is again the t-axis, and I have 0 labeled there. So I want to figure out whether the second derivative is positive or negative on the left and right of 0. So let's look at the formula for the second derivative. So we want to know if I look at second derivative. If I look at the second derivative, on the left side, on the left of 0, is it positive or negative? Negative. On the right of 0? Positive. Where is it concave up? Concave up, and here it's concave down. Right? So C is concave up and concave down like this. Everybody agrees? Okay. All right. So what's the final step? Sketch C. Okay. Sketch C. All that work that we did, finally we're going to put them together in order to sketch the graph of C. Now, I'm going to give you 2 minutes here, 2 minutes only, and whoever comes with the graph within that 2 minutes will be given 2 extra points, okay? 2 minutes. I already labeled some points here. What points did I label? What points did I label? I labeled the X and Y intercepts, right? X and Y intercepts. I also labeled at what time you get those points. And I also labeled the point at t equals to -1 and t equals to 1. What are those points? Remember, I got -1 and +1 as the critical points for the function y. If you look at the function y, when we did the analysis for y, I got -1 and +1 as the critical point. That is, the behavior of y changes at -1 and 1, right? So I also plotted the points corresponding to those. They also happen to be the points where you have the horizontal asymptotes. T equals to 1, t equals to -1, you have horizontal asymptotes there. Also, t equals to 1, t equals to -1, those are the points where y changes behavior, right? Those are the critical points for y. Okay, 1 more minute. $30 seconds. You got it? Okay, can I see yours? Can I see yours?
Very well.
Start now.
Okay, good. Go ahead. Okay, so I think he's got it. Okay, let's see how we can come up with the graph. First of all, think about this problem in the following way. I'm going to make an axis for t here separately, and I'm going to look at the critical points here. The critical points, I'm going to look at t equals to -√3. I'm going to look at t equals to -1, t equals to 0, 1, and +√3. And what I'm going to do here is that I want to draw the curve part by part. So first of all, I want to draw the curve for t between negative infinity and negative root 3. So what is happening between negative infinity and negative root 3? A couple of things that you have to know. Between negative infinity and negative root 3, what is happening to x? What's the x value at negative root 3? The x value at negative root 3 is 3, right? And the y value at negative root 3 is 0. Up to the point negative root 3, what is happening to x? X is decreasing. X is decreasing. What is happening to y? What do I know on the left side of negative root 3? I know that x is decreasing. I know that y is increasing. How is x decreasing? X is decreasing from infinity. How is y increasing? Y is increasing from negative infinity to 0. X is decreasing from infinity to 3, right? You agree with that? I'm just using the information I obtained before. X is decreasing there, so it's decreasing from infinity to 3. Y is increasing from negative infinity to 0. Remember, y was increasing in that interval. Right? What else do I know? I know concavity. I know that it's concave what? Until negative root 3, it is concave down. So put them together, what do I get? Well, the only possibility, if you can think of, is that the curve, so y is increasing from, so y is coming from below x-axis, x is coming from right. So together, I'm getting something like this. Right? It shouldn't be like a straight line. Sorry, let me delete that. Because it's concave down. Let me make sure I have the concavity clear. Okay, now it's a little bit better, I guess. So it's concave down. It's concave down. It is y is increasing to 0, x is decreasing to 3. That's the only possibility. Now, what is happening between negative root 3 and negative 1? Between negative root 3 and negative 1, x is decreasing from 3 to 1, and y is increasing from 0 to 2. Because if you look back, y is still increasing. So I know that what's happening here. It's still concave down. I know it's still concave down. So that's what's happening. Now what's happening between negative 1 and 0? Between negative 1 and 0, x is still decreasing. So x is still decreasing from 1 to 0. And y is now starting to decrease. So it's not... y is now decreasing from 2 to 0. So that means you're going to get this. Okay? Right? Y decreasing is still concave down. X decreasing as well. Now, after 0, x starts to increase. So x now starting to increase. And x is now going from 0 to 1. Y is still decreasing from 0 to negative 2. So that means you get this. And it is concave up in that interval. And then I guess you can imagine now what's happening. After t equals to 1, up till root 3, you're coming back to the point 3, 0. You are concave up, coming back to 3, 0. And y starts to increase again. X is increasing still. And what is happening after that point 3, 0? Well, after you get there at root 3, right? And after root 3, x is still increasing, right? And y is increasing as well. So what's the orientation? Coming like this, going down like this, coming up like this, coming up like this. Okay? Is everybody okay with that? A lot of work to get there, right? In WebAssign, you will be given choices for the graphs. You can actually do it easier just because you have the graphs in front of you.